Hello, everyone. I'm happy to kick off this session dedicated to the role and impact of digital technologies in the railway industry. It's a topic of great relevance and interest, and I'm happy to see so many people here today, eager to learn more about digital transformation in the world of railways. I would like, before starting, I would like to introduce myself. I'm Clarissa Batangelo, and I'm the Key Account and Business Development Manager at Move Solutions. And I'm in charge of the South African area, Australia, and France in Europe. Then I will introduce also the other speakers that host this webinar. The Professor Gräbe from the University of Pretoria, that he will be happy to show you his project on railways. And then we will have Stewart Chaperon from TANDM. Before to start, I would like to say to you that the webinar will be recorded, so the records will be available as soon as the webinar is ended, and you will receive the record by email. So let's start to this session. There is also a Q&A boxes where you can write it down, all the questions you may have during the webinar. And then when the webinar is ended, we will reply to you by email with the help and the support of our technical and engineers, so we can better explain and answer to your question and doubts. So this is the agenda of the webinar. We will explain you who we are, Move Solution Stories, and our products, why monitor, and the different types of monitoring, when and why. Then I will leave the floor to the Professor Gräbe, and then to Stewart from TANDM. So our company, Move Solutions, is a trusted leader in a smart structural health monitoring. Our wireless system offers a remote and continuous and comprehensive analysis of the health of the structures by integrating cutting-edge Internet of Things technology with a structural health monitoring practices. We promote more sustainable and resilient infrastructure. Then talking about our story, Move Solutions started, we was born like very early, because we was born around 2017 as a response to the infrastructure crisis. I don't know if you remember that in Italy, some years ago, occurred the collapse of the Morandi Bridge. So we decided to start investing in the research and development of electronic solution aimed at addressing the problems of material degradation and lack of asset monitoring. Since then, we have been working on designing technology and data processing tools for innovative structural analysis. Now we have a lot of installation around the world, because we have installation in USA, we have installation in Australia, in South Africa, and all around Europe. Talking about our system, we provide the hardware part and the software part. So we have the sensor and the software with an IoT platform for a comprehensive monitoring. We provide innovative technology for static and dynamic, and also geotechnical and environmental analysis of all types of infrastructures. As you can see, our sensors are like closed boxes with battery inside, and they are battery powered, and they are completely wireless. And they communicate and send all the data that we lands on our IoT platform. It's an all-in-one system that combines unique wireless sensor and management platform for remote and continuous structural health monitoring. As you can see here, this is our system architecture, where we have all the sensors that are installed in the specific infrastructure, buildings or dams on the railway tracks or another all kind of structure, and they communicate through the LoRaWAN protocol to a device that we call it gateway. The gateway has a SIM card inside and that use 3G and 4G network, so the internet network, and send all the data to our server. All the data will end to our IoT platform. And in our IoT platform, you will see all the raw data, but not just the raw data, but also the elaborate data. So there are available a lot of algorithms divided in for the specific infrastructure. So we have, like, for example, the railways tools, the overlays. You will see specific tools and specific graphs where you were able to analyze all the data remotely, directly from your laptop. Sometimes happens that our customers already has their own platform. So we can also provide the MQTT, the FTP and API. So you will be able to see all the data directly on your interface without using our platform. But for example, with API, you will be able to use also you will see not so the raw data, but you can use also our APIs on your interface. So why monitor? The monitoring is very important because, as we can see also in the early days, because for example, the big earthquake that occurred in Morocco and the other earthquake that occurred, for example, in Tunisia, can be a problem for all the structures. So it's important to monitoring them and to do an early detection of structural issues. You will able to, with a monitor, to be a proactive asset management and try to have a better source allocation, complying with regulations. For example, with our vibrometers, you were able to set specific vibrational standards and try to see if the thresholds are exceeded and if you are compliant with the regulations, and of course to enhance safety. For example, some years ago, I don't know if you remember the big explosion occurred in Beirut. Some years ago, we installed some sensors on the silos of Beirut, and thanks to our sensor and thanks to the platform that sent the alarm of the status of the silos, the company that was monitoring the silos of Beirut were able to put in safe the old sites before the silos collapsed. So it's very important to be proactive and use this kind of technology. Then we see that we can do different types of monitoring. For example, thanks to our sensor, we can do a static monitoring, a dynamic monitoring, and a geotechnical and environmental. So we have a comprehensive approach for safer and more effective asset management. So we develop specific solutions for different types of monitoring in order to analyze all the structural behaviors that are important for assessing the stability of and the health of a certain structure. Talking about static structural health monitoring, the static monitoring measures, for example, slow varying parameters over a long period of time, such as an inclination, such as a rotation, static displacement, for example, and crack monitoring. So we provide products like to monitor in a static way. For example, our tilt meters. The tilt beam is a beam with our tilt installed on it. And you can use our analog node and our single channel node that there are our data loggers. For the dynamic part, the dynamic structural health monitoring is used to handle dynamic loading such as frequencies, dynamic displacement, model forms, vibrations, and acceleration. In fact, with our sensor, for example, our accelerometer, you will able to perform the model analysis. You can use our vibrometer to see the vibration. Another sensor that we are very proud of it because is a sensor that its technology is patented by us, as it's our DEC sensor, and its specific use is for monitoring the bridges, viaduct, and overpasses, and you are able to see the dynamic displacement over the time. Regarding the geotechnical and environmental part, the focus of the geotechnical monitoring is, for example, on the ground movement, settlement, slope stability, subsidence, and any changes that may affect the stability of a structure. Environmental monitoring instead looks at factors like air quality, water level, soil contamination, wind speed, and anything that can have an impact on a structure degradation. So you can use our nodes, such as analog node, single channel node, and tilt meter to perform the geotechnical environmental monitoring. So here you can see all of our applications. So there are all of our industry where we are working on it. So we have installation in construction site, monitoring, for example, the vibration. We have many installation on bridges. We have installation on railway monitoring, that is the focus of this webinar. And in other infrastructure like dams and other structures like this. So now I give the floor to Professor Hans, who will explain his project. The professor used our sensors in a railway track in South Africa. Specifically, he used DEX and accelerometer and tilt to monitor a railway track. So thank you, Hans. I give you the floor.
Thank you very much, Claire. It's really a privilege for me to present this project today in collaboration with TANDM, our partner here in South Africa, and then also with Move Solutions. I'm entitling this talk Smart Railway Monitoring, and I will be describing one project that we are busy with currently here in South Africa. So just to give you a bit of a strategic background on what we are doing, rail is very important for us here in South Africa, and we are investing a lot in skills transfer and education. We invest in railway research and development, and we are gathering around us technical expertise and facilities to really make a difference in the world of railway engineering. So as part of that, this project is one of the big drivers. We are pursuing excellence in railway engineering. So you might ask, what is smart track infrastructure? And I think it's important that we quickly define smart track infrastructure in the context of railway engineering specifically. And here it is important for us that we have a feedback loop and that we can improve our decision making. So we need to monitor, measure, analyze, and then we complete the loop by communicating based on the data that we receive from our sensors, and then we can make decisions that improves our maintenance and the operation of our infrastructure. So one could therefore say that the digital railway is all about creating value at new frontiers and creating value in our core businesses. So this includes proactive decision making, contextual interactivity, global connectivity, journey-focused innovation, technology, real-time automation, and then also linking people, ideas, and things. We have you could say, a playground where we experiment with Industry 4.0 technologies, and that is our Engineering 4.0 development in Pretoria in South Africa, where we have a laboratory auditorium. We are busy with the planning of a test track, and we also present our training in railway engineering at this facility. So this brings together everything we need to really excel in railway engineering. The facilities we have at Engineering 4.0 includes equipment for carrying out a variety of track tests and accelerated testing on all track components. And this equipment is used basically on a daily basis. But we also venture out into the field, and that is why I'm focusing today on a field project where we are doing real-time and long-term monitoring of a viaduct. Now, this viaduct is situated on a rapid rail service line. It is between Pretoria, Johannesburg, and the international airport, or Tambo. This rapid rail project was constructed in 2010. It consists of a double line with a maximum speed of 160 kilometers per hour. Currently, the peak time between trains is about 10 minutes and off-peak 20 minutes. So it's quite a well-utilized and busy railway facility. As you can see, we have, at this point, we have a viaduct, and then we have a huge embankment, and that then gives rise to differential settlement and a difference in behavior. And one of our research projects then is to manage the difference in track behavior between the embankment and then also the viaduct. And this proved to be an excellent application for the MOVE sensors. What we've done at the beginning of the project is to choose a control site in addition to the transition site. So in this map, you can see what we call U36. This is where we have the viaduct transition, and then about 200 meters to the left, we have U35. This is our control site. They are chosen fairly close to one another so that the dynamics of trains moving over these two sites would be similar. So the speed would be similar. The traction, whether the train is in acceleration or braking, would also be very similar. So we are comparing the behavior and of the trains and then also of the infrastructure between these two sites, U36 and U35. Of course, we had to choose what instruments we would use, and for this project, we basically chose the deck sensors measuring deflection, and then also an accelerometer in X, Y, and Z. So what you can see here is that on the track, we decided to measure vertical sleeper deflection with the deck sensor, and then also have an XYZ accelerometer also on the track. And then we decided to also measure vertical deflection of the viaduct. And we did this at both sites. So at U36, the transition, and at U35, the control, all of this was installed. The infrastructure of specifically the communication is as was presented by Claire in her introduction. So we use a LoRaWAN gateway. Our sensors communicate with the gateway, and then we send the data from there to the management platform. All the diagnostics that are included, namely frequency domain decomposition, and then also displacement density probability functions and fast Fourier transforms. That's all available, and I will show some examples of that shortly. Just to show you how we did the installation, it was done in 2 phases because the line operates for most of the day and also into the evening. We had to plan this carefully. So the day installation included the installation of the power supply and communication and also solar panels for this application. And then during the night, we installed all the sensors on the track. In addition to the move sensors, we also installed some of our own sensors at this specific site. Here you can see a better view of the system that we've put together. So we have a solar panel, and then we have a battery with a solar charge controller, and then all the communication, the LoRaWAN gateway, etc. And then we have the sensors. Here's the 2 sensors, the deck sensor and the accelerometer on the sleeper, and then some of our own instrumentation adjacent to that. We also installed optical track deflection measurement. So we have a webcam next to the track that looks at the rail and then records a video of a train passing. It's triggered by movement, and then we have a secondary measurement of deflection also. And then here on the left, you can see the deck sensor that measures vertical deflection of the viaduct. On the move platform, we configure everything together. So here we have the transition U36 and the control U35. And then we have for the sleeper and the viaduct, the deck sensors and the accelerometer, and then similarly for the control site. So this is the landing page where you can access the different sensors. And then very conveniently, we can have a look at the events at one of these sensors. So here you can see the deck sensor, which measures the vertical displacement. And this is one train with 4 coaches or cars passing our site. And you can then also see the peak-to-peak maximum deflection. So for the highlighted one, we have a 0.84 millimeter peak-to-peak deflection. And this was on 15 February of this year. We can then go on from here, and we can look at something like a frequency response of the displacement. And then there's various other tools, analysis tools, that we can use. For us, it was, of course, very important to have alarms and triggers. So with time, we carefully changed the resolution of the different sensors because that's configurable. And then we also configured alarms. So here you can see the alarms on the deck sensors. On the sleepers, we have 2 millimeter alarms. And then on the viaduct, we have 1 millimeter for an alarm. And then also here on the right-hand side, you can see the triggers that were carefully configured. This was really depending on exactly where we've installed it. And you can see all the triggers are different. So we had to fine-tune them with time. But the sleeper at the transition, for instance, has a trigger of 0.4 millimeters. And then the sleeper at the, the 0.4 is at the transition. And then at the control, it's 0.1. And then the viaduct would have two different triggers. Just to show you some of the very useful applications of it, we've identified what we call flat wheels. So that's wheels that causes high impacts on the track. And here, for instance, you can see that the first axle has a significantly higher deflection caused by that flat wheel. So we can identify those, and because each event is logged against time, we can pinpoint the exact vehicle and then correct that. And then we can also look at this is looking at the rolling stock, but then if we then look at the frequency response of displacement of, for instance, the viaduct, we can detect changes in this frequency spectrum and then look at health monitoring and what that means for our infrastructure. Moving on to some of the trends. At this stage, we have slightly more than 1 year data covering a period of more than a year. And you can see at the installation, this is in July 22, we've moved through an entire seasonal change up to September now, where we can see maximum temperatures rise in our summer and then decline again in winter. And we are moving into summer again, and we have that full spectrum. We can see here the maximum of the sleeper and the minimum, those two solid lines, and then the viaduct, which is the concrete structure with a slightly lower maximum temperature and a higher minimum temperature through this cycle. Also interesting, if we look at the accelerometer, we've witnessed a slight but observable decline in the accelerations. So this is indicative of consolidation of the track with time. So that does not have any resemblance with the temperature changes, but it shows a clear decline as the track consolidates, and that will change then when maintenance takes place. This is, of course, acceleration in the vertical z-axis. And again, we measure this at all the different positions. If we then look at the deflection trends, you can see here that since installation, the sleeper with the highest deflection decreased. And as we move into summer now, there's a upward trend again. We believe that this is all temperature related. The two graphs here at the bottom, those are the viaduct measurements at the control and the transition. They remain stable, and that is as we would expect. Now, bringing the data together enabled us to determine a very clear relationship between the deflections that we measure and the temperature of the rail. And here you can see for the two sleepers that we instrumented at the transition and the control, the daily peak deflections per train events ranging between 0.8 or 9 millimeters to about 1.67 millimeters, and then also some trigger events that would give us an alarm that is sent on cell phone and email. And then you can see the clear relationship between the temperature of the rail. This is a trend that we wouldn't have been able to establish without this 24/7 monitoring with the MOVE instruments. That really brings me to the end of my presentation, and just a couple of conclusions. We are really extremely happy with the performance of the system. It's been very stable, and it's given us reliable monitoring over a year. The data ranges from 4th of July 2022 to today, and giving us more than a year of data. Since the baseline date, we can see the seasonal trend in temperature changes. And then on an event scale, we see a strong temperature deflection relationship that we've established through this work. In the long term, there's a downward trend when we look at vertical deflections and accelerations, and that indicates track consolidation. The real-time monitoring with LoRaWAN communication enable us to push through alarm notifications and to put together some very informative trending graphs that I believe is very useful, not only for our research, but also for the client and the owner of this transportation system. So in future, we are looking at expansion of this project and using more of the sophisticated trending analysis that I have just touched on here and there. So with that, I want to thank you once again, our partners TANDM and also Move Solutions. Thank you so much for the opportunity to present some of this exciting work to a wider audience. I thank you. Thanks very much.
Thank you, Hannes. Good morning, everybody. My name is Stewart Chaperon. I'm a test and measurement application support and service engineer at TANDM here in South Africa. I'm just going to give a quick company overview of where TANDM is and how we partner together with Move to bring the products to industry. So who is TANDM? TANDM is, we want to be your first choice test and measurement partner. So as soon as you think test and measurement, if you have an application or requirement to do any testing or measurement across any engineering sector, we want to be your first choice partner that you turn to and give us a call and see how we can assist to make your measurement a reality. So what does TANDM stand for? Well, TANDM originated from the words test and measurement. So it's T&M is another way to pronounce it. And it's an association or a partnership. And that's how we want to see our relationship with you as our customers, as a partnership going forward. We partner to find the best test and measurement solutions based on world-leading technologies, and making sure that we find the best application or best hardware and equipment for your specific application and testing requirements. So when people hear the word TANDM, they often don't think of engineering initially. Some may think of a tandem bicycle, where you've got the guy in the front doing all the hard work and the guy at the back just going along and pedaling together. Or some people may think of tandem skydiving, where you've got the person in the front, the client really enjoying the trip and having all the fun, and the instructor at the back guiding and making sure that the skydive is a success and that everyone makes it to the end in one piece. And we like to see ourselves as both ways in this partnership, that we can either help lead and guide the project from the front, or we can be guiding from the back and assisting and making sure that the project is a success and that you get the measurement results that you desire. So TANDM is very proud to be a technical partner with Move Solutions. So we are the first line of support for Move Solutions in South Africa. Not only supplying the hardware, but also we are able to assist in the installation, the designing of the system, the specifications, and the support and management of the system once it's installed. So as a whole, what TANDM provides is we like to see ourselves as a fathering company and making sure that we upskill industry and provide training together with all our equipment and services we provide. So we want to transfer knowledge to industry and make sure that when you get a project or equipment, that you know how to use it to the fullest capabilities, and don't need to get hold of TANDM every time you're wanting to use the equipment, but you are fully trained and capable to use it. We also have pride ourselves on our support. So that is a critical part of what we do, is providing support, whether it's over emails, WhatsApp, Teams calls, or coming out to site and assisting on supporting on the products. We have a big support team, and we really push the support component. And then the services. So if you don't have the capabilities or the manpower to do the installation or the measurement yourself, we do have capabilities to assist in conducting the measurements, the installation of the hardware, and assisting you to make the measurements a success. So our solutions, we cover everything from the sensors that you're going to bring into your data acquisition system, then a variety of measurement systems, which include the Move solution stuff on the structural health monitoring, more advanced test systems like vibration, shakers, and climatic chambers, not only on the physical measurements, but also in vision systems. So we've got everything from high-speed vision to machine production, inspection and monitoring for production control and ensuring that processes are correct. And then also the software side to do the durability and reliability and data processing. So we've got very nice software packages dedicated to making the data processing as easy as possible and as repeatable and reliable as possible. So one thing I want to highlight here is very exciting that we have our TCC for 2023 coming up. So this is the TANDM Community Connect Conference, where we invite our industry partners and customers to come and present on measurements and projects that they've worked on through the year. So it's a good opportunity to meet fellow colleagues or people in industry that are doing similar work to you, and get inspired by the engineering community in South Africa. We also have a selection of international presenters. So it's not only local projects, but also international projects. And registrations are open for that. We'll have some demos there as well, and equipment. And it's good to meet and see each other in person. So we've got two sessions. We're going to have the first one in Pretoria and the second one in Stellenbosch. And early bird registrations are open for that until the end of September. Then if you want to get in touch with us, we're on all the social media platforms. We like to stay very active on these platforms, making sure we keep everyone up to date with latest trends, equipment, hardware, projects that we're involved in. So be sure to follow us on all the different social platforms if you want to stay in touch and just see what TANDM does and what equipment is out there and available. You can scan this QR code and it'll take you to all our contact information for the company, and feel free to contact us if you would like to talk about the measurement project that you have. Thank you very much. Thank you to Move for assisting in putting this webinar together, as well as to Prof. Gräbe from the university. It's always exciting to see the work you've done with our equipment and the good results that you are getting. Thank you.
So, thank you so much. We have come to the end of our webinar. Thank you all for your attention and for following and subscribing to our webinar. I would like to thank again our speakers, the Professor Ahmed, who explained his project to us and showed how monitoring can be approached with digital and IoT solutions, and how this way this solution can add value to, and how this system can be used in different types of monitoring. And last but not least, I would like to thank to Stewart Chaperon and his entire team from TANDM that are helping us every day and today in organizing this event. And just a few last words. I will share my contact. If you have any kind of question, doubts, or request, you can contact me to my email address or directly to info@movesolution.it. And I will also announce that we are planning another webinar. Our next webinar will be led by our North American sales director. The webinar will be on preventive monitoring and will be in October the 12th on Wednesday. Here there is this, the QR code if you want to scan here to register. And if you would like to be updated for our next webinars and for all of our news, you can subscribe to our newsletter with this QR code, or if you want, there is the same QR code and boxes on our website. So thank you all again, and have a nice day.